A warm welcome to everybody today to the Bolin Lecture 2018. My name is Astrid Söderberg-Widding and I'm the president of Stockholm University. And a particular welcome, because I hear that some of you are here because you skipped your gym class. I think that was a very smart decision. Climate research at Stockholm University is very broad and a very important field of research for us. And here, the cross-disciplinary Bolin Center, which arranges this yearly lecture, is indeed an asset. And I'm very pleased that the center is not only doing excellent research, but also reaching out to society, so that this annual lecture is now part of and the peak of the ongoing Climate Festival, which is held for the second time this year. I'm also both proud, honored, and pleased to welcome Professor Veerabhadan Ramanathan, RAM, to Stockholm University as this year's speaker. I know you're a member of the Swedish Academy of Sciences since many years, so in a way, of course, it's like a homecoming. But nevertheless, we are very glad to have you here and eager to listen to your lecture in pursuit of the common good. So my warmest welcome. But first, let me hand over to Professor Cindy DeWitt, who will give a background to the Bolin lecture.
So, yes, welcome to Stockholm University. And I want to particularly welcome you on behalf of the Faculty of the Natural Sciences here at Stockholm University, because they are the ones hosting this lecture every year. And I just want to say that this lecture series, I can't remember exactly how many there have been, but there are quite a few. It's been going on for many, many years. And they're named after Bert Bolin. And for many of you, Bert Bolin is maybe an abstract name. Many of us knew him. He passed away a number of years ago. Bert Bolin was a professor here at Stockholm University in meteorology. And as a young person here doing his research, he started studying the carbon cycle. And it was in understanding the carbon cycle that he began also to pursue his career, in a sense, in climate research. And he is maybe our most prominent climate scientist throughout our history in that respect. We do have Svante Arrhenius, who in a sense was the first professor at Stockholm University who actually identified that carbon dioxide might be a problem, could cause a greenhouse effect. But this was in the 1800s, so it was a long time ago, and it was before fossil fuel use was so widespread. But Bolin began to understand a little more of these implications of what fossil fuel burning and our potential to change the environment, change the climate by releasing these climate gases could actually mean. And because of this, Bert also had the leadership and the drive to be involved in the creation and leading of a number of different international groups working with these questions. And perhaps the most famous of these is the Intergovernmental Panel on Climate Change, which he helped actually to create and then led for a number of years from 1988 to 1997. And during that time, he was the chair of 2 of the IPCC assessments that have come out every so many years that tell us just how much the climate is changing. And in the past, a couple of assessments have actually been able to draw the conclusion that we are actually changing the global climate and the global warming of the planet. And IPCC, because of the work they were doing, actually won the Nobel Peace Prize in 2007, which was a great achievement as well. So Bert Bolin means quite a bit to many of us who work in Stockholm University and with climate research, and the Bolin Center, of course, has his name as well. So with that, I'd like to introduce Professor Nina Kirchner, who will introduce our Bert Bolin climate lecture for this year, Ramanathan.
Thank you very much, Cindy. So as of now, I'm the last person standing between you and Ram's lecture, and I want to make it very short because I've already listened to Ram this morning. He gave a science seminar from 10 to 11, and it was a fantastic lecture. There, the lecture room was too small. We actually had to move to a larger room because we were allowed for safety reasons to stay in that room. So I will make it very short. So my pleasure is now and honor is to introduce Ram. You are a distinguished professor of atmospheric and climate sciences at the University of California at San Diego. And Ram has contributed, inspired, and led the field of atmospheric and climate sciences for more than 40 years. Ram has received a number of prizes and honors that include the highest prizes you can receive. It's the Taylor Prize in the US and the Volvo Prize in Sweden, for instance. Ram has also been elected to all different sorts of academias, the US National Academy of Sciences, the Royal Swedish Academy of Sciences that was already mentioned, and Ram is also in the Pontifical Academy of Sciences. That means he is giving advice to the Pope, actually on the issue of climate change and how we address it. Ram has an incredible number of publications in the highest ranked journals. These are for specialists, but you also, Ram, you follow Bolin by communicating science to all of us who don't understand all the nitty-gritty of the details. And I just want to close with a quotation from the nomination that we received when you were suggested as the climate lecturer. And here it says, Ram follows in the footsteps of Bert Bolin by also translating the science to concrete advice on policy actions and to inspire climate scientists, the broad public in both the developed and the developing world, and world leaders. And now you are here to inspire us, and I know that you are recruiting climate warriors, and with that I leave the stage to you, and I'm looking forward. Welcome, Ram.
Thank you very much, the President of Stockholm University, Chair of the Bolin Center Governing Board, and Professor Nina Kirchner. I think as your President said, this is like coming home for me. I've been guest of Professor Henning Ruther several times in this university. I started working in this field about 44 years ago, and since the last 10 years, I switched my interest to solving the climate change problem. I'm not anywhere close to solving it, but I'm thinking about it. And the reason is, the first 35 years, I basically took instruments and make measurements. Every time I come back, it'll be some bad news about what's happening in the planet. So now looking back, I think of all my papers as obituaries, thinking about something in climate changing pollution. So that's why I changed to the solutions and announcing new births. Okay, so I'm going to talk to you both about the science and what we are thinking is happening to the climate, and then switch on to solutions. I must tell you, this is one of the best audiences I've had. So many high school students. I think you are the perfect audience for what I'm going to say. So why is that? As I'll talk to you soon, in about 12 to 15 years, our planet is going to transition to what we call dangerous climate change. And you will all be between 25 to 35. And you are the ones who are going to solve this problem. And it's the duty of my generation and my next generation to give you the tools. The key thing to remember is this is a solvable problem. Unlike many problems on the planet, it can be solved, and we are not solving it, not because there are no solutions. There are abundant solutions. My own view is that very few have realized how imminent and how serious is the climate change threat, okay? And certainly, I'm following the footsteps of Professor Bert Bolin. I know him, and I served in his IPCC. I think he was the first who realized the seriousness of the situation. Back in 1980s, the remarkable insight, and ultimately, I'm just listing various things he has contributed to, and all culminated in IPCC. It just simply wouldn't have happened without him. And without IPCC, I don't think this field would have even gotten the attention it has. So IPCC had a huge impact. So let me take you to how the science was done. So my own work is that, I joined a postdoc after my PhD at NASA in Virginia. I joined a team of 4, and we designed a satellite, Earth radiation-bedded satellite, to directly measure the greenhouse effect of the atmosphere and trying to figure out how it's going to change. Okay? So let me take my graduate student lecture on climate change science and reduce it to 30 seconds. Okay? So as we show in this cartoon, the fundamental energy source for the planet is sunlight. Okay? Not all of the sunlight is absorbed by the planet. It reflects about 30% back. These are the clouds, the ice. When you fly, you see these white clouds. They're reflecting sunlight back to space. So we call that the albedo. So 30% is sent back to space, but the remaining 70% heats the planet. And then the planet, in response, gives this off as heat energy. Technically, we call it infrared radiation. Okay? That's, in a simple nutshell, the paradigm of climate and climate change. But then what happens is the surface is trying to give off this heat. The intervening atmosphere, primarily carbon dioxide and water vapor, acts like a blanket. So it's an exact metaphor for the greenhouse effect. A blanket keeps you warm on a cold winter night, not because the blanket gives any heat, it just traps your body heat. Okay? That's exactly how the gases do. They trap the infrared heat coming from the surface, so then the surface has to get hotter to radiate to space. So keep this blanket metaphor. I'll show you how I measure the blanket thickness using actual measurements. Okay? So yeah, this comes next. So you see the satellite. It has a scanning radiometer. It measures the heat radiation coming from the top of the atmosphere. So you can see that the unit is watts per meter squared. Watts is a unit of energy. When you say 60-watt light bulb, that's what it is. The surface is radiating close to 400 watts per meter squared. All that can escape is 268. So the balance between the two is the thickness of the atmospheric blanket. It's about 130 in those units. Primarily from water vapor, about 25% from CO2. That's Mother Nature. What we have been doing by dumping these pollutant gases, I'll tell you what they are, we know within 20%, we have added 3 watts extra energy we have trapped. That is, we have made the blanket thicker from 130 to 133, about 2.5%. You can't hear me? Sorry. Yeah, thank you for letting me know. I know the last time I was in Omaha, Nebraska, there were an audience of 1,000. After I finished my talk, people raised their hand and said, we couldn't hear you the whole time. So I'm glad you gave me early warning. So don't worry, I didn't say anything important so far. So now let's talk about the problem at hand, carbon dioxide. Fossil fuel is basically hydrocarbons, hydrogen and carbon atom. So when you ignite it, sorry, oh, it's this. How about now? Is it okay? Yeah. So when you burn that fuel, the carbon in the hydrocarbon attaches with oxygen and becomes carbon dioxide. Okay? The problem with the carbon dioxide, once you release it, for example, let's say you took a bus or you came in your car, the carbon dioxide which escaped your tailpipe, about 50% of that will be there for nearly 100 years. And about 20% will still be in the air for 1,000 years from now. Okay, so that is the main issue with carbon dioxide. So since the time James Watt invented his famous the improved steam engine, we have dumped or emitted 2 trillion tons. That's 2 followed by 10 zeros into the air. And by precise measurements, particularly my colleague at Scripps, David Keeling, we know 45% is still up there. 950 billion tons blanket covering the Earth. Just imagine the sheer magnitude of this. That's equal to 450 billion Volvo cars circling the planet. And unfortunately, since in the gas form, you can't see it, okay? So that is the blanket which is trapped out of the 3 wards, at least about half of that. So what is the, I'm sorry, let me go back to this. This is the problem a famous Nobel laureate from this campus, Svante Arrhenius, quantitatively determined. He looked at the blanket effect of CO2, did a heat budget at the surface, and first time alerted the world that carbon dioxide, if you double it, it could cause a warming of 4 to 5 degrees. He was not interested in the pollution, he was more thinking about ice ages. But anyway, the first quantitative estimate of that came from this campus. So people are not, at least in America, they're very skeptical about climate change. So what are some of the examples you can give to verify your theory? This is how scientists do. We do thought experiments. I'm showing you what's called the inner planets. Venus, closest to the sun, then Earth, and then Mars. Okay, let's just compare Earth with Venus. The incident, if you ask, Venus is 425 degrees Celsius, right? You can fry an egg on its surface. And the Earth is just 15. So how did Venus get so hot? If you ask many people, including physicists, they'll say, oh, it's obvious Venus is closer to the sun. Of course, if they can see Venus receives twice as much sunlight as Earth, but Venus is completely cloud covered. Earth reflects only 29%, Venus reflects 70%. That's why it's one of the brightest objects in the sky. So actual sunlight going to the Venus surface is less than Earth. So what makes it so hot? Venus has 200,000 times more CO2 than Earth. 96% of Venus is carbon dioxide. That's the reason it's so hot. So we have at least system comparison. So until 75, ever since Arrhenius' work in 1895, people thought the main issue is carbon dioxide. Then in 75, I stumbled into this finding, no, there are other pollutants we are putting into the planet. This one I looked to was chlorofluorocarbons, and it suggested 1 ton of CFCs could have the same effect as 10,000 tons of carbon dioxide, super pollutant. Okay, the chlorofluorocarbons are used then as refrigerants and propellants. Of course, we have banned them because of their effect on ozone. So that opened a Pandora's box. Other pollutants were added. I'm showing you here the thickening of the blanket by various pollutants. First is carbon dioxide, the biggest one. Next is methane. Methane leaks from natural gas pipes. Methane is made in paddy fields, cattle, etc. Halocarbons, and ozone. And then black carbon, it's not a gas, it's a particulate. What comes out of your diesel truck? A ton of this soot coming from your diesel cars has the same effect on climate as 2,000 tons of carbon dioxide. Okay? So we call this methane, HFCs, ozone, and black carbon as short-lived climate pollutants. But not all the stuff we do warms the planet. They're also cooling. We put aerosols like sulfates, nitrates. Professor Henning Ruther played a major role in our understanding of this. So we are thickening the blanket on the one hand, and then putting mirrors on the blanket on the other hand. So our best understanding is the blanket thickening is 3 times more than the cooling effect of the mask. So that's so far our theoretical understanding. Okay? Just to summarize, certain gases act like a blanket and traps the planet's heat, so the planet warms up. Nature gave us a blanket, we are making the blanket thicker. Okay? So by 1980, it became clear to me this problem is a lot more severe than we thought. So we decided to test the theory. That is what scientists do. When you have a theory, you make a prediction and then test that prediction. So we made a prediction that if this theory was right, the planet should warm above the natural noise, and the signal will show up. He said, if it doesn't show up by year 2000, then we know we have exaggerated something or we are missing some part. So that was made in 1980. This was the report released first in the 2001. The Bert Bolin was just finished that report. I'm showing you the global temperature record. These were collected by tens of thousands of thermometers around the world. And show from 1850, you can see how nature by itself goes up and down. And we were saying, when will the signal shoot past? So we made this prediction in 1980 when this planet was still not that warm. And then in 2000, you can see the warming went above the background noise. And it was then 2001, IPCC released, we are seeing a discernible change in the warming. Okay, I want to talk to you about a few other predictions which came true. The second is, Arrhenius was the first to suggest there is something called an amplifying effect. He said when you heat the planet on the air will hold more moisture. It's basic thermodynamics. And water vapor is the most powerful greenhouse gas. So this is what's happening. You put CO2, right? You trap more heat, and the planet heats up to get rid of it. But when it heats up, water vapor increases. There is a basic thermodynamic prescription. Water vapor in the air increases by 6%. So the blanket is getting even thicker. So the planet has to get warmer. So he used this feedback, and then others in the like Professor Manabe and others have done tremendous work. But you see, I'm by nature, don't trust anything unless I can see it and measure it. So we went back to that satellite that measured the thickness of the blanket and did it over the whole globe. And then we compared that with the water vapor. First, on the bottom figure, we see the water vapor. You can see how the water vapor is tremendously high, about 60, and decreases by a factor of 10 by the time you go to Stockholm latitudes. And that factor of 10 can be predicted by one simple equation. Okay? And you see the greenhouse effect, how it's large in the tropics, it decreases. And then we plotted it to show the way the blanket became thick as it increased the temperature was very close to what was predicted by Arrhenius. The third prediction which came true was that in the 1960s, Russian meteorologist Budiko and an American meteorologist Sellers, they said, if you warm the planet, the Arctic is going to warm much more. Simply because what keeps the Arctic cooler is the sea ice and snow, which reflects 80% of the sunlight back to space. But when you warm the ocean, the ice would melt, and then more sunlight. And we decided to test it with the same climate satellite, which I helped launch in the 1980s. You see on the top, 1979, our sea ice. You know that the sea ice has decreased, particularly September 1, by 30%. And you can see where the sea ice disappeared, the ice was gone. The open ocean is very dark. So what we showed was the whole Arctic was getting darker and darker. What do I mean by darker and darker? It's absorbing more sunlight. Okay? So like that, there are these 5 more predictions, all have come true with data. The only difference was the observed feedbacks were much larger than the model. The sea ice albedo feedback, all of the IPCC models are a factor of 2 smaller. Okay? So I hope what I've done to you is build trust in climate change. We are not hand-waving with models, every part of it. I just showed you my work. There are thousands of scientists who have checked 1,000 different parts of this. Okay? So with that knowledge, let's see what's in store for us. As of 2010, we have emitted 2 trillion tons. About 45% are still in the air. In another 12 years, we would have dumped the 3rd trillion tons. Okay? And if we still don't do anything about this, another 10 years, 4 trillion tons. But I'm going to talk to you about solutions by which all the high school students, when you are 25 to 30, you will become the climate warriors and bend that curve. And there are tens and hundreds of solutions available. Okay? So let me tell you the next 30 years. These are my predictions based on all the things I showed you. This was published a few years ago. In about 15 years, we would exceed the threshold for what scientists call dangerous climate change. So climate change is not 100 years from now. It's not even 50 years from now. It is 10 to 15 years from now, we will see major warming magnitude. Okay? And in 35 years, there is a 50% chance of going beyond 2 degrees. What do we mean by 2 degrees? I held a meeting at the Vatican last November with World Health Organization, and some of the data present to us shows 3.5 billion would be exposed to deadly heat. And many living particularly in the extratropics say, oh, it's not going to come to us. It's all in the tropics. In 2010, Russia suffered this lethal heat stress, 40 degrees Celsius heat wave, and at least 15,000 perished. Okay? And then the second is, this is from the Max Planck Institute, 2.5 billion would be exposed to viruses which are rarely seen in these latitudes. Dengue, chikungunya, Zika, and many. So, and then we would have set the stage for sea level rise of meters or more. Let me take you beyond. This is something I think you will help prevent. If society doesn't pay attention to this, this is one of the Princeton University model prediction for droughts, 2080 to 2100. I've been talking to my governor and the farm workers. I don't think farming as practiced in California is going to survive. I don't know how many of you know 90% of the almonds and walnuts are produced in California. And look at the entire Mediterranean. And then look at Amazon. If this model prediction comes true, I think it's about a 5% probability it will happen. It's not clear. The world as we know could survive. Okay? So this is based on, there's a paper which came out based on paleoclimate that it is showing the present. And why are they showing 125,000 years ago? That was the previous interglacial Eemian. The planet was warmed by about 1 degree. We are already at 1 degree, and the sea level went up by 6 to 9 meters. You have to go back 3 million years to see 2 to 3 degree warming, and they think the sea level was tens of meters higher. The issue is that that doesn't mean, remember I said 13 years from now we'll reach 1.5? That doesn't mean sea level will go up right away. It has its memory, the glaciers ultimately. It could take centuries, but we would have set the stage for that. And then can you reverse it is not clear. So what I'm focusing on the red curve, okay, this is 2100, where we are saying it's 4 degree warming, but there is a 5 to 10% probability that we were wrong. The warming could be much larger. Of course, there is a 5–10% probability the warming could be much lower. So we cannot be precise about the future. That is where our understanding is tremendously uncertain about future. All we can give you is probabilities, but if it is 5 degrees and warmer, more than that, ecologists and anthropologists are saying that at least 20% of the species would be extinct and set the stage for extinction. And then the population increase, they claim, has already put 50% species under risk. So they're saying if you get 5 degrees or more, there could be so-called mass extinction. It may take centuries to get there, but we are setting the stage, okay? So imagine that, the age of humans, the Anthropocene, a famous scientist, Paul Crutzen, who graduated from here, got the Nobel Prize. He popularized this term. It is clear we have become a geologic force. And climate change is an icon, okay? The hope is we would evolve to solve this problem. So, cheer up. No more bad news. I'm going to talk about solutions, okay? My thing to start working on solutions, what happened in 2004, I turned 60 years old. I was in the Maldives launching some UAVs, and I got an email, and it started with Pope John Paul II. What would you do if you're sitting on an island, email from Pope John Paul II? I thought it was a junk email. I deleted it. And it turned out it was an invitation for me to join the academy. I must tell you, we meet every 2 years. It's a small academy, just 80 members, mixing with theologians and physicists, biologists, and particularly social scientists, made it clear to me, I cannot remain in my shell as a scientist. I'm not going to get my hands dirty. I realized it's my duty to think about the solutions, okay? So an opportunity came in 3 years ago, 2015, I was asked by the University of California to lead a group on thinking about solutions. How do we bend that curve, okay? And we came with 6 clusters and 10 solutions. The center one is scientific pathways. What do you need to cut, okay? But what was very interesting, what emerged on the top was societal transformation. Mind you, we had social scientists, we had anthropologists, we had engineers, we had economists. So expecting to come with technology would be on the top. In fact, most studies you see, including IPCC, technology is put first. My problem is that if technology was the only problem, we would have solved it by now. Just take where I come from, San Diego. Solar produces power at 8 cents a kilowatt hour. Coal is 12 cents to 10 cents. We are still using fossil fuels. So I'm going to talk to you about the societal transformation. Then, of course, comes governance, markets and regulations. For example, Sweden has a carbon tax. That's one way to do that. And technology measures. other thing which came to the top was ecosystem management. There is a huge potential there. Doing things which make sense would also cut the climate change problem. But the thing is, I waited for 3 years because our governor was here. I thought Jerry Brown is going to do something. They're doing their best, not much. So we formed a coalition. I call it California Collaborative for Climate Change Solutions. I just called for this 3 months ago. Every campus in California immediately joined. Caltech, Stanford, Berkeley, all 10 campuses. Apparently, such a coalition has not happened since World War II. What it told me, it's definitely nothing to do with my leadership skills. Each of these scientists have figured out, we are seeing that cliff. It's not very far. So we all have to, in addition to doing our science, work on the solution. We propose 50 projects. Our dream here is identify innovations, do the demonstration in our cities. Minimum population is 50,000, that's our. And then find out which of these are scalable, and then bring our local industries and policymakers to take it further, okay? So what do we need to do? The solutions. 4 things. We have to work on 4 levers, okay? Which means you have to form in a team of 2. Between the 2 of you, you have 4 hands, right? To pull on 4 levers. The first is the carbon lever. Just decarbonize the economy. So what do we mean by that? Electrify everything, all end uses, and generate that electricity using renewables, solar, wind, even nuclear, hydro. Okay? That's what it is. It's as simple as that. Of course, it's very complex. You're perturbing the whole economy. The thing you have to remember is that when you cut down CO2 emissions, the planet could heat up because you're removing these aerosols, right? Cooling aerosols, temporarily, short term. So what you need to do is at the same time pull the second lever, which is short-lived climate pollutants. Remember I said black carbon from diesel is 2,000 times more potent? Its lifetime was only a week. So you stop black carbon emissions, its heating disappears within a week. So you need to do both so that you can see that curve. I put carbon dioxide only, see how long it takes to respond. The short-lived climate pollutants immediately bends it. So when you add the 2, you can see how the lever is bent. But unfortunately, we have delayed actions so much that we're all realizing those 2 are not enough. You have to suck that carbon dioxide out of the air. We are finding you may have to take as much as 500 billion tons out from the air. Then we can keep the planet safe. How do you do that? There are at least 6 to 8 different methods. We are going to test 4 of them in the field in California to see which are scalable. Okay? So the bottom line is, it's a solvable problem, and we can solve it in 15, 20 years. That's the time we have. So I'm going to skip it. Maybe I don't know how much time I have. So this is important. The key argument I hear when you say decarbonize, the industry says, oh, it's going to ruin the economy. What California and Sweden has shown is that that's not necessarily true. You can see how SE is for Sweden. The Swedish GDP and Californian GDP almost increased by the same amount, while their carbon emissions were coming down. I'm not claiming because we brought the carbon emissions, GDP is increasing. All I'm saying is they are decoupled. So I want to take you now the societal transformation issue. I see the climate change problem has become a huge moral issue. As scientists, I'm not supposed to use the word moral, I'm supposed to say ethical. But I think the time for such niceties are gone. We got to call them what it is. One of the issue is 60% of the pollution comes from the wealthiest 1 billion. They're all over the planet, okay? The poorest 3 billion, they have not even discovered fossil fuels. They are still burning firewood for cooking. I'm going to take you to one of the villages in the video, if there is time, how I think of the world as there are two worlds. The one world we all inhabit in. Just next door is this other world, okay? And they have nothing to do with this, but we know what will happen. Mega droughts, they're going to get wiped out first. Okay, so that's the second moral issue. Just to preserve my lifestyle, I'm doing something which is going to affect children and grandchildren. The high school students could be my children or grandchildren, and generations to come. Okay? So those are the moral ethical issue. So one of the things we did, we started a project to cut down the soot emissions from these cook stoves. It was really killing close to 2 million women and children, just inhaling that. So this is work I did with my daughter. She started her own NGO. What she did was put smart sensors in this improved stove. If they use it, she gets the data. We calculate the reduction in carbon emissions because she's not cutting as much wood, and then connect her to somebody wealthy in California. They send that woman carbon credits. Okay? The second societal transformation, this is what I briefed Pope Francis. Mind you, this happened in 2014. We had top economists, many Nobel laureates, including Paul Crutzen was there. And I was asked to brief Pope Francis. And our conclusion after 3 days, mind you, these are physicists and chemists and biologists, we concluded finding ways to develop a sustainable relationship with our planet requires ultimately also a moral revolution. What is that moral revolution? Changing our attitude towards nature. Nature is not infinite. You keep taking, it's going to get depleted away. You have to put it back. And the second is change our attitude towards each other. Because climate change is a common good problem. Our CO2 emission in Sweden will affect the whole world. Likewise, because so we all have to be together. The next is, I think what we need to do is to educate our young. Not only paralyze them with bad news, but give them the tools. So we started this climate solutions course. It's a hybrid course. Lectures from the top leaders in the world were taped, and the students are supposed to listen to the lecture, review the lecture before they come to the class, use the class to discuss the solutions. So we launched it in 6 campuses. Now we want to launch it with the slogan, California tomorrow. California today, the nation and the world tomorrow. Our aspiration is we want to create 1 million climate warriors. That's how I think this problem is going to be solved. Bottom up, people asking for solutions and people doing it themselves. Okay. The other thing, major movement happening is that this is the meeting we organized at Vatican with Lancet Commission and WHO. Finally, the doctors are realizing this is going to become a major health issue. Just imagine the viruses I talked about, heat stress, right? And the third one, which was uncovered by a Harvard physician in that meeting, mental health. Imagine you're losing your house to fires, floods, right? So we are now, we are calling for an alliance between science and religion. And I'm not being naive that science and religion can work together, not in many areas, but in nature. Our aspirations are aligned. We say protect nature, and they say protect creation. and particularly in the US, that's the only forum I can find to talk to people directly like this about climate change in a non-political forum. In the US, climate change has become so politicized. Now we are forming alliance with healthcare, right? Doctors, and whether you are a conservative or liberal, you go to the same doctor. I must say our JAMA, they are now coming. We published an editorial there. So many, many physician associations are alighting up on climate change. So that's another new opportunity opening up. Can anyone know, have I exceeded the time? I have another 2 minutes. I'm fine? Very good. I'm finally coming to telling you what you can do, right? I mean, I'm old enough, so I can tell you what to do. But take a look at this movie. I spent 4 months in sabbatical. I'm going to show you 3 houses. One, I had breakfast, then lunch in a different village. I started from South India, went all the way up to north, and see how we are left 3 billion people in dark ages. Oh. Can somebody tell me how to start this video? I thought it was, no? Yeah, oh, thank you. I had breakfast, she's preparing my breakfast. It's 6 in the morning. It was a fantastic breakfast, I must tell you. See all the smoke. This is noontime, okay? And look at her inside her house, how dark it is. While the women are working, this is what boys do in the villages. And the daughter is going to get wood for the night cooking. You can see most of the trees are almost gone. Now this is the lady I was staying with her. She's getting water for our dinner and next day shower. Look at how carefully she can't afford to lose 1 drop of water, because there are 8 people who are depending on those 2 drums. I was absolutely stunned. So while they are suffering like this, I'll show you a scene next, just 10 kilometers away from here. Biggest water source, because it's going to the cities. And this is the resort just next to her. So now this is to our high school students. The first thing I have learned, and I'd like you to pass a lesson to you, knowing is not enough. You must apply. Willing is not enough. You must do. So why are they laughing? Smiling? This is what they have to do. I'm showing you just a handwritten graph or temperature change starting from the Ice Age 20,000 years ago. Then we slipped into the Holocene, warm climate, right? And then what Kirchner calls the Anthropocene. That 2030, that's 12 years from now, we are going to pass the 1.5 degree threshold. When we do that, we have exceeded the climate of the Eemian period, 130,000 years ago. By 2080, we would have gone to a climate not seen for 20 million years. So we have 15 years to bend that curve, okay? I hope many of you here would get educated on the science of climate change and the solutions. It's not going to happen by, disciplinary science. It has to be interdisciplinary. You have to understand the human dimension of it. You have to understand the economics of it, the technology side. It's just going to take a whole new generation to solve this problem. And I can assure you, it can be solved and it will be solved by you. Thank you. Oh, thank you. Okay.
Thank you very much, Ram, for a very inspiring talk. You have outlined a challenge that is very difficult, and I hope that it's not only the young people that you mentioned, I hope that we also continue to have leaders such as you that both do the science and have this moral responsibility that you can lead these youngsters, these climate warriors, towards the solutions. I would very much like to hand over this or the other microphone to questions from the audience. From here it's always a bit difficult to see, so I will need help from here to see who has questions. Yes, here is one.
It was absolutely wonderful and inspiring. Thank you. I'm from the United States originally, and unfortunately, I even have a certain family member and even younger family members who are very skeptical about climate change, and unfortunately, they also pass some of this on to the children. I'm wondering what you think and what you suggest about these people, the next generation, who are unfortunately being raised with an extreme amount of skepticism to the same thing. And I think even some of the most powerful children soon, who will be the richest, are also getting the same.
Thank you, Mayor. It's a very critical question. Thank goodness it doesn't apply to Sweden. It's an American-centric problem. But you know what I find in the US now? We have treated those who don't see our viewpoint or accept with us as something evil, bad. So the problem is created from both sides. And what I have found personally is that I give a lot of talks in churches now, okay? And as a scientist, we are able to reach out to the people. I'll tell you some of the antagonisms I've seen, NGOs, they're well-meaning, but they've been taught by communication experts, you got to say that the problem is solved. So I have seen NGOs sitting on the table pounding, we understand everything about climate change. It's all solved, take action. I won't take action if somebody told that to me, because as science, you never settle anything. My reason for taking action is this uncertainty. If we knew precisely what that warming is going to be, even if it's 4 degrees, maybe we can adapt, we can do something. We don't know that future. So what I found is that, that's what I mentioned, because I was talking to churches, the leader of the Evangelical Church reached out to me, Leith Anderson. He's a reverend. He oversees 30,000 churches. He came to our meeting at the Vatican. Apparently, first time an evangelical leader has come to a Catholic church. So I think I find the doors can be opened, provided scientists here directly reach out. I'm not saying you can reach out to public just through church. That's my vehicle. Because if you have to understand, let's say it's your parents. The problem in America, it's become so politicized. Climate change has got mixed with abortion, gun control, everything. So they're relying on certain TV to get their news. So we have to reach out to them. We have to be patient to them. I feel so confident in saying this to you. If you explain the science of this, how it's done, I think we can change minds.
Is there another question or comment? Yes, please.
Yes, so this might be a bit of a sensitive topic, but I was thinking about your slide comparing the GDP of Sweden and California growing while the carbon emissions go down. And I'm slightly skeptical because do you think that decreasing carbon emissions can go with our economy and our how much you consume? I know that Sweden is a country that has lowered carbon emissions, but we have also outsourced most of our production in other countries.
Yeah.
We buy things from China. Sweden owns coal mines in other countries. So do you think, yes, lowering carbon emissions can go with our economy model that we have right now?
It's a great question. I think yesterday Professor Arjen Gustafsson raised the same issue. Remember, my graph just goes from 2000 to 2016. I can certainly tell you what happened in California during that time. Okay. For example, in San Diego, where I come from, our mayor is Republican. We are already putting 30% of our power from renewables. And Oakland, same thing. They have cut their emissions for the particular use. So the reductions we are showing is not because of export to some other territory. It's the local consumption. How much carbon we generate for power generation. You